Good evening, everyone, and welcome to webinar series by IITACB. IITACB is set up by IIT alumni from across all IITs to enable networking amongst IIT alumni and establish collaboration between IITs and the industries together. So also IITACB is recognized by MHRD, and now the center is in Boomsandra, Bangalore. So today's speakers for this excellent talk is Professor Preeti Rao. She is professor in the Department of Electrical Engineering, IIT Bombay, with a research interest in speech and audio processing. She has been actively contributing to computational research for Indian classical music, including participating in efforts such as the Comp Music project on music information processing for non-Western genre. She has served as co-editor for a special issue of Transaction of the International Society for Music Information Retrieval on cultural diversity in MIR's Music Information Retrieval. And second speaker is Hema A. Murthy. She is professor in the Department of Computer Science and Engineering at IIT Madras. And her research interests includes speech processing, music information retrieval, and computational brain research, where her primary goal is to use machine learning and signal processing in tandem. She has been actively involved in culture-specific approaches for the analysis of Carnatic music. And she is also a fellow of International Speech Communication Association and a fellow of INE, Indian National Academy of Engineering. And she also received IBM Faculty Award in 2006 for her work on speech synthesis in Indian languages. So she has been involved in a lot of government projects in India. And now she is also leading the speech technology effort for Natural Language Translation Mission funded by Government of India, and where the primary objective is to the speech machine translation. So our third speaker for today's webinar is Ajay Srinivas Murthy. He is an applied science manager at Amazon Alexa in Bangalore, India, where he works on large-scale automatic speech recognition system for Alexa, and he got his PhD in music technology from Universitas Pompeu Fabra, Spain, and he has diverse research interests and experience in the area of speech, audio, and music signal processing and machine learning. So for audience, please post your questions in QA box, so which will be taken up by the speakers and the moderators during the discussion. And over to Professor Rao.
Yeah, I'd like to actually begin by, thanking IITACB for this very kind invitation, to come and present here. It's a real privilege. And thank you to everyone in the audience who is, interested enough to register and, attend this online meeting. So what we are going to do is, we are all in this area. So I'll begin by just introducing and telling you what this field is about. And give you a little bit of background of where we come from, because that's a very common question about why are we working, and how are we working with music, coming from departments like electrical engineering and computer science. So let me begin. Okay, so about this field, it's a field called MIR, Music Information Retrieval. It's a small but very active global community. And most of them have this audio signal processing background. And the typical problems that they address are, like automatic music transcription, music recommendation engines, characterization of style, tagging, automatic tagging of music, music summarization. And there is also an interest group in the analysis of music for musicology studies. So for all of these, actually, the problem statements and computational tools, as you can imagine, because we're dealing with something like music, are culture dependent, right? All the different musics of the world are, so different from each other. So this is what makes the field really interesting to us, to actually see how one might bring in Indian music and, you utilize similar tools for very similar kinds of exploration. So we've been working in this area for a while, and in the year 2010, actually, we have this series. So all of us have a original background in speech processing, and one of our winter schools was themed on music information retrieval. And since then, our activity has been strengthened. We actually were all part of a large European Research Council funded project given to UPF Barcelona, very prominent music technology team. So we were partners in this Comp Music project that actually created a lot of resources and spurred a lot of new work in this area, especially for non-Western music genres. So just to give you a feel of what are the resources required for such work. So comp music essentially, was aimed at, applying or developing tools and developing corpora, because data and corpora are really important to this kind of work for non-Western genres, of which there wasn't a whole lot, because data means not only free access to music recordings, but also a certain amount of annotation and labeling, that makes them suitable for actually carrying out research. So they have multiple collections: Carnatic and Hindustani, Makam, the Turkish music, Jingju, the Chinese music, Andalusian, and so on. And we also have developed research data sets for Indian art music. So both the Carnatic and the Hindustani. So this is actually a very positive step in the right direction of establishing corpora and getting people together to identify problems and work in all these different non-Western musics. We had some recent activities, like we had a Spark project on computational musicology and Indian musical instruments, where we conducted a couple of workshops in 2019. And we had, a decent amount of interest, some collaborators who came in from outside India to speak on, some of their research on Indian, music and musical instruments. And one of the outcomes of the workshop was this book that we recently brought out, which was a collection of articles by people with very diverse backgrounds, including, mechanical engineers, electrical engineers, computer scientists, musicians, musicologists. So this book is available for free access on Google Play. And very recently, we hosted this international conference in Bangalore. So this is the MIR Community Conference for the first time in India, which just goes to attest to the kind of visible presence we now have as people working with Indian music. Okay, so of course, not to say there wasn't work. There's been some really great work. For example, ITC, SRA, the Sangeet Research Academy in Kolkata had a scientific research department, and they brought out some excellent publications. They had a small but very active expert group who actually did analysis of audio, worked with waveforms, and did some really interesting studies. There's also an FRSM conference that's been around since 1990, which regularly hosts, invited talks and, conference, papers in the area of music, apart from the area of speech. So SRA also had a big role in that, but a number of institutes like IIT Kanpur, IIT Kharagpur, and so on have been actively contributing there. And finally, of course, there's a long-standing project there was called Music in Motion, OTRIM, by NCPA. This was, came out of, Dr. Bhaba's dream of developing a notation system for Indian music to capture all these, nuances and, make it easier for analysis and possibly also for reproduction. So this was a collaboration with the University of Amsterdam, and they have an excellent website where some of the outcomes of the project are displayed. Okay, so what's the motivation for this kind of work, and where do we look for the problems? So they come from the fact that theory is an important part of most classical traditions, and that's true also of Indian art music. There are many texts and there are many treatises that discuss music theory, for our classical music. But it turns out, and this is very aptly put by Professor Iyengar, who's ex-IISc, I think, Department of Civil Engineering. And I came across this lecture that, he wrote, where he has actually very systematically reviewed a set of Sanskrit texts across the centuries that discuss music theory. And what he concludes that there is a lot of technical vocabulary that has been developed, but then the terms remain vague and not quantifiable. So one solution to closing this gap between what's written in the textbooks and our understanding of it is actually to study music performances, because the practitioners, the performers, they've actually internalized the grammar and the aesthetics, through this oral tradition. They've learned it, and maybe by analyzing their performances, we can, help to close some of the, those the vague, define better some of those vague aspects and so on. So that's a prime motivation for this kind of work. And of course, if we use computational tools to do it, there are musicologists who do this, but if we use computational tools, and we can do it at scale, we can analyze a lot more music. And finally, the overall goal is to improve the theory by actually looking at practice. Okay, so how do we work with music from audio recording? So the major dimensions of music are melody, rhythm, and timbre. So the melody and rhythm are based on the pitch content. So we should be able to extract the pitch, of the performer from the audio recording. Rhythm is based on timing information. Timbre relates to instrumentation, voice quality, texture, and so on. So all of these high-level musical attributes can actually be obtained from signal analysis. And that's really our primary expertise, where we are coming from in the area of signal processing. Okay, so just to give you a very quick idea, so here is a very short snippet, of 8 notes played on the guitar, and you see the waveform, and we see what we call the time-dependent spectrum, where you can see each of the notes represented by its fundamental frequency and its overtones. And this is the kind of representation available for us to extract, the pitch, the timbre, and so on. So I'll just play this, and you can see how the fundamental frequency increases as we move from along in time. Okay, for a singing voice, we have a more complex spectrum because we sing lyrics. There are different words being sung. So not only we do see that the pitch, which is related to this harmonic movement, is actually continuous and moving in a fairly complicated manner, but we also see that the timbre changes. For example, the distribution of energy along the frequency axis keeps changing as the lyrics, the sounds of the lyrics change. Oh, sorry. I wanted to move to the next slide. Yeah. Yeah. So what do we do? So typically, of course, musical excerpts, especially the ones that we want to analyze, actually quite complex. We not only have the main voice, but we also have a lot of accompanying instruments. And if we want to analyze, for example, the melody, for example, to understand better the raga characteristics, we would have to extract the melody of the voice from a very crowded spectrum, which has all the accompanying instrumentation. So I'm going to show you the next slide, which actually has, sorry, I meant to show the next slide. Yeah, which actually shows this extracted melodic contour in yellow superimposed on the, the spectrogram. So I just play this and you can follow along that this is indeed the melodic contour. Okay, so that was essentially, showing the extracted melodic contour from this. So there are tools available and they actually don't work perfectly. And there is some amount of, tuning and, adapting required to the particular kind of music you're looking for. For example, in this music, we have particular kinds of background instrumentation, and we also have particular ways and styles of singing. So all of that really needs to be taken into account to build something that actually tracks the pitch of the main singing voice. Okay, so if you want to apply these tools to musicology questions, so what are those questions? So the questions stem from the following. We would like to ask, how is the mandatory grammar, that is how the raga definition, how is it being satisfied in performance? Now, raga grammar actually gives us a theoretical framework that supports creativity and in improvisation, but also, makes it clear how to maintain distinctiveness of each raga. Then another question could be, are there other consistent practices that performers observe for a raga apart from what is actually written in the grammar? And then finally, we might be interested in understanding how the artist improvises, that is, uses the stock knowledge of the raga lexicon or grammar in new ways. And our approach would be to build computational tools for the melody extracted from performances and the raga grammar towards the above goal. Okay, so I'll take a couple of examples. So one problem that we worked on was to look at this grammar, and it's interesting to look at allied ragas because we have a situation where there are two ragas which are very close, and we could maybe validate some of our tools and techniques by seeing whether we can actually discriminate them automatically. right? So we have these two ragas, Deshkara and Bhupali, and they have the similar tonal material. Ragas also are defined by their phrases. Further, there are some, apart from the main notes, there are some other indications in, for example, the rain parenthesis, which tells you this is a very short note played in passing. It also tells you something about the intonation, right? So although the notes have the same name in this particular raga, they're intoned slightly higher than in the other one. Now, if in order to do this, maybe the most natural thing is to extract the notes, but it turns out that, the variation of the melodic contour is so complex and so continuous that labeling of notes is actually requires great expertise, right? So in fact, it requires a knowledge of the raga itself and a lot of, experience to be able to put down notes. There's no one-to-one correspondence between this very continuously varying, undulating contour and the note labels. So we resort instead to what we call the continuous pitch distribution. So we divide up the octave into much more fine bins and then, find out the strength of each of those pitches in those bins. So these are essentially fine bin continuous pitch distributions. Now, what does this allow us to do? This allows us to compare the two ragas in terms of a set of performances. So this is over a couple of hours of one raga and a few hours of the other raga. And we look at the pitch distribution, we can see there is a difference indeed, although they use the same notes. So these are the 5 major notes of the pentatonic raga. But we see that, the tonal hierarchy, which notes are important and which notes are not so important, comes out. The fact that the re is very slightly realized also comes out. So there's all this kind of information available in these representations, which, we can use to understand that, yes, indeed, we captured some main aspects of the grammar of the raga. We can also look at the phrases. For example, if you look at the Garesa phrase and we try and determine what features discriminate the Garesa phrases of these two ragas, the same phrase, but obviously realized differently in the two ragas, we find that the re duration and the intonation of the ga is what makes them distinct. And that's what we show on this bar graph, where in fact we see that the note re is very short, and we also see that the note ga intonations are, separated, clearly separated. So all the performers and all the performances we analyzed actually, did the following, and we get a glimpse into how the raga grammar was actually put into practice. And we also get a quantitative relation about, now we knew it was higher, but how much higher, right? It's all measurable now that we have this performance data. Okay, finally, what are the new insights we get? So for example, we did an experiment where we took segments of the performance to see how much raga identity was in the segments. And we found out, for example, that the best, which is the uppermost curves, happens when the full concert is analyzed, as opposed to taking, let's say, half of the concert or a smaller segment. But on the other hand, if you use the first half, that is the initial part of the concert, is almost as much raga information as the full concert. So that's also something we know, that performers tend to give raga cues or, demonstrate the raga more completely in the first half of the performance. And then finally, looking at improvisation, these are two performances by the same, musician of the same raga, but at two different times. And we can see how the distribution of the pitches changes across the two performances. In the one case, he's slowly expanding from the beginning to the end. The other case, he's actually utilizing notes throughout the raga notes across, octaves, right from the beginning. Okay, so this tells us improvisation is something we could systematically study, because it applies to how it is developed, although we are still using all the characteristics of the ragas in terms of the notes and the phrases. Okay, and I'll just talk briefly about another project. This is only to give you glimpses of the kind of computational work that is possible. So we are looking at a completely different problem, and that is sound and gesture relationship in music. So vocalists in Indian classical music are known, it's very, very unique. They're known to use a wide range of manual gestures to accompany their singing. That is, they move their hands and so on while singing, although they don't really need to do it for sound production. It's not like playing an instrument. The gestures are linked to tapping coordinating. It could be some visual imagery that they're trying to sketch, or it's typically also the flow and the organization of the melodic phrases. So we are studying the complementarity between gesture and melodic movement in the context of Hindustani vocal performances. So this is a data set. These are videos, created at the Durham University in the UK. So they have these studio recordings of singers whom they are capturing in order to study the gestures together with the audio. So they have the 9 ragas, 3 singers. At a subsequent time, we've expanded this by contracting with the studio in Pune to add more singers, to the data set. So we have this available to us. And what we did is, we did the audio the way I explained earlier with the melodic contour. But we did extracted from the video what is called the skeleton joints, because there are these softwares such as OpenPose available that actually allow you to track the joints. So here, for example, we tracked the 2 wrists. And then, of course, did a bunch of video processing to come up with time series. Okay, so how did the wrist move in time, for example? And we also have the melodic contour, like how did the pitch change in time? So we use this information together and also in isolation to see how much raga information is embedded in the video gestures, for example. And what we find from these confusion matrices, of course, audio is quite good. You get a near diagonal, result when you, try and identify raga from the audio excerpts alone. Video is much more scattered, telling you that actually gesture ends up being very singer specific. It's much more idiosyncratic than audio. Everybody sings the raga somewhat similarly, but they don't gesture similarly. On the other hand, we also found that bringing video in actually helps with some of the audio identification, right? So there were some cases where the presence of the video or the gesture information actually helped remove ambiguities. And this was particularly true in ragas such as Miyake Malar and Bahar, where the tonal material is the same. So there's more audio confusion. And in these cases, we found that the video actually brought in value. So I'm going to conclude this presentation with just a video of some of this work, which shows the predictions we made. For example, just an excerpt showing what the true label was, what the audio predicted, what the video predicted, and what we got by combining the audio and visual predictions. So let me just play that. Okay, I think the laser pointer, yeah. Okay, so yeah, that's all I had for my presentation. Yeah, let me just. Oh, I'm trying to go to the next screen here. Okay, here we are. Yeah, so thank you, for your attention, and you'll be hearing more about the techniques and the different problems, also from Professor Hema Murthy and from Ajay.
Well, thank you so much. I mean, I just want to open up the floor for like a couple of questions. Please use the Q&A. I already see one question there, and we'll try to answer them offline or probably take it up here as we switch over. So we probably can take 1 or 2 minutes now for questions, and we can use. We can also have some time at the end of all the presentations for some questions as well.
Should I share my screen or?
Yes, ma'am. Yeah, please go ahead. We'll set up our next presentation.
Can you see my screen now?
Yes.
Yeah.
Okay, I mean, so we could use the Q&A section for any questions, but maybe we could get started with the next one.
Yeah, I think so. Preeti has already given a very good background to the kind of work that we do, and she's the one who started with a lot of audio work. I still remember her wonderful thing on recognizing so Hindi film songs. I don't know whether you remember this, Preeti, long time ago, and that was really something which got me excited too. And of course, I got into this work because of Javier Serra when he came and was looking for collaborators. I was not really working on music, but I'm very passionate about Carnatic music in particular. Listen to all kinds of genres. And since she's already talked about it, I'm going to say we've been working on both melody and percussion. Since Ajay is going to talk about percussion, I'll just talk about some work that we have done on melodic analysis. Before that, I just want to, why do we want MIR for Carnatic music? I think all of you might have, at least I am a frequent visitor to this website called sangeetapriya.org. And idea is, can we organize these collections? I want to look for a specific composition sung by some X by Z. Then finding it is a little non-trivial. Then have they done an elaboration? Have they not done an elaboration? And which school do they come from, and so on. And even in Taniya Arthanam, for example, I'm very particular when I listen to concerts that all the three artists are kind of together, because the concert is a story for me. And of course, learning can be a very big motivation. How do we mine a particular kriti by a particular artist? And the whole thing started out with, where do we start? So we started out with Carnatic music concerts, because concerts are a story that an artist tells. That's my way of looking at it, that from the beginning to the end, there is a story that the artist tells us when they perform. And for those of you who do not know, a concert in Carnatic music is made up of a sequence of items. Items correspond to different forms. Each has a specific characteristics. Generally, melodies are not repeated. Melodies means ragas are not repeated except in thematic concerts. The most important thing in Carnatic music is what is called a kriti, and it consists of an alapna, a composition, Pallavi, Anupallavi, Charanam, Miraval, Swaraprastara, solo. There are some Rakti ragas where there are some big 6 ragas in Carnatic music, which generally you will find in any concert. And the Ragam, Tanam, Pallavi can be chosen in any of the, in fact, many times they choose Hindustani ragas for this, and it's very similar to the Pallavi, but it's like more like the Khayal in Hindustani music. But they use very complex rhythm cycles. And there are other, things like Padam, Javali, Viruttam, Slokam, Varnam, and so on. And a concert generally consists of about anywhere between 6 and 12 items in a concert. A concert lasts about 2.5 to 3 hours in Carnatic music, a general concert. And this is kind of a finite state machine, which kind of represents a concert, start of a concert. Then there could be a composition right away. In fact, in Carnatic music, you'll find that the first composition will be a Varnam or something like that. Or it could be for a composition, for example, it could be a alapna, there could be a violin alapna. There are different kinds of instruments, even veena is being accompanied, and you will always find all these are interspersed with applauses. And then after, there could also be, for a particular composition or like a RTP or a kriti, there could be a Taniya Arthanam, and then you go through the end of the item, start again, and in the end of the concert. And towards the end of the concert, they will have all these small things. And I think she already mentioned about what melody is. For those of you who may not know what it is, when you listen to some music, what is it that you hum? And that's what is melody when we're looking at. And she already showed you some examples, so I'll not go through that. And there are many applications in the West: chord recognition, synchronization, alignment, cover song detection, and so on. And and she already talked about pitch, which is the fundamental frequency, which is what we analyze and debate. Whereas in Indian classical music is based on what we do is the artist chooses the key for every composition, unlike Western classical music where the key is kind of pre-decided. And the first note is what we call the tonic, and we need to normalize this. And to just give you a difference between Western music and Indian art music, it's basically, Indian music is based on the natural scale, which means that the ratios are all integer ratios. And here there are absolute pitches, relative pitches, is carefully annotated. There's hardly any annotation. You'll find that school to school there are various variations, and the significant improvisation that is there. This is just to give you, if I take the melodic histogram and plot it, you'll find that I took the same C major, Bilawal in Hindustani and Shankaravarnam in Carnatic. And Shankaravarnam is actually one of the somewhat more flatter ragas in Carnatic music, but you will find that the bandwidth, for example, for Carnatic music for each of the peaks, here is Ga here, Sari, Ga, Ma, Pa, Da, Ni, that's Sampurna raga, and you find that Da is quite flat both in Bilawal and in Carnatic music. Big variation in pitch, as Preeti already showed in the context of Deshkar and Bhopal. And this is just to give you an idea of what the natural scale is. This is the natural scale, and these are the ratios, whereas harmonic scale is 2 to the power of 1 over 12, and they are not actually integer ratios. Now, what is interesting about Carnatic music is it's without a score, or in classical music for that matter. And not only that, the pace of the song is also decided by the performer. What is slow, what is Velapakalam, what is Madhyamakalam, what is fast, and so on. I'm just going to play you one. This is the same composition sung by 4 different artists. And look at this, just the Pallavi. This is the Pallavi line of a composition composed by Tyagaraja in Kambodi. And this is MS, that was first was Sanjay singing it. This is Krishna, Team Krishna singing it. Let me play the last one. The significance of what I played was Sanjay sang the Pallavi line in 10 seconds, MS Subbulakshmi took 12 seconds, TM Krishna 14 seconds, and Savita Karthik took 16 seconds to sing this. So basically, the analysis now, for example, the time is relative, so how do we take care of all of this? And that's the most important, that is a very important problem. And also we notice that the Shrutis are all different. The tonic that the person has chosen, for example, Krishna and Sanjay have about 138 or between 135 and 140 hertz. Whereas if you look at Savita Karthik, she is 220 hertz. MS Subbulakshmi is between 178 and 200 hertz. As she grew older, her Shruti also came down. So basically we have to normalize with respect to tonic. And then these motifs, for example, has to be also normalized for time. And this was the, so basically we look at motif as a sequence of notes that make up a melody. It's kind of free from, not necessarily time. And we looked at some various things. And as I already talked about the tonic, I'll just play one, this is the tonic, one played at one tonic. This is sung at around 140 hertz, which is his normal pitch, and this is sing at 6 So first thing that we have to do is normalize this, and this is what we did. And we found that in Carnatic, for example, it's not always that the tonic is not easy because the saw is not always the tallest peak. This is an occasional Hindustani concert where the sa is the tallest peak. In fact, in ragas like Marwa, you hardly hear the sa at all. So what we did was we did a culture-specific approach to find the tonic itself. We took the pitch histogram and looked at the ratios and made sure that if the lower shadja, for example, is 100, then 150, then 200, then 300 and 400, then when all the peaks are matched, then we call it the tonic. And this worked really well. We also did a machine learning approach where I said, one of the things that we also do is we look at, here for example, this is an excerpt, spectrogram of an excerpt of Carnatic music. And we found there are these gaps over here where only the drone is playing, where the tanpura is playing. So what we did is we detected these gaps using signal processing and then used a bag of words approach to find the tonic. So this was another culture specific way of doing things. And then we used once we have tonic normalized, then we said, okay, the first thing that everybody asked, can you give me an app which will identify the raga? And we started out with that, but we realized it was quite difficult to get this done. So we had musicians tell us what the motif is, and we try to spot these motifs. And for example, this is a Kalyani of a musician. And this is for another musician. Same motif. So all these things have to be matched. So we developed what is called, so we identified what are called these stationary points, which are the points where there's an inflection over here. And then we normalized for time, as I said, because we know that it's not necessary that everybody keeps to the same time. And we did an analysis, and we did did a lot of work. So we use these to measure the extent to which a swara is being intoned. We determined the stationary points per sparse, use that to reduce the search space. And then we, of course, did some interpolation to correct for pitch errors. And we spotted the motifs. And here is the typical Bhairavi motive that is there. And this is what it finds. So we were able to spot these motifs, but the big problem was that we had to get an artist to identify. Then we said this is not good enough. Then we realized that actually, if you look at Carnatic music, as Preeti was already saying, initial portion in Carnatic music, the kritik is very important, and the Pallavi line is actually replete with motifs. And we said, can we detect these Pallavi lines automatically and use that for Raga ID or whatever? And here is a spectrogram after some processing. This is a query that is there. This is an unmatched segment, this is an unmatched segment. And here is a matched segment where you can actually see the contour in the spectrogram somewhat matching between similar and dissimilar segments. And it's not showing up over here. And we said, how do we find this? And what we do is we don't know what the query length is originally. So we did some various experiments. Normally, for example, the Pallavi line can vary anywhere between 2 to 3 seconds to about 6 seconds. And then we varied these lengths. And then finally, we did a lot of experiments and actually simply multiplied the Frobenius norm across multiple segments. And we were actually able to get the query. And here is the result. This is Prasanna Venkatraman singing. Magna sunil bashakile kapote Magna sunil bashakile kapote Magna sunil bashakile kapote. Despite percussion, it was able to pick it up. And these are very So this is what we did, and using that we were able to distinguish between, we could tell, for example, from this how many times the Pallavi was repeated, how many, and then this is the Anupallavi. At the end of the Anupallavi, you see the Pallavi segment again and the Charanam. And the problem was we had to get the initial where the Pallavi started, and we also developed another algorithm to give the start of the Pallavi. And here are some examples. Let me play Hindustani. Another example. The third example is interesting because she repeats. So she's repeating the Mainahi Makana, but still it picks it up as the note. And then what we did was we got all the Pallavi lines, and from the Pallavi lines of various compositions, we identified motifs for ragas and used them in various kinds of analysis. So we got this for Bhairavi. This is taking Pallavi lines across. So this is Shankaravarnam. So if you notice, the ga is there, and which is very distinctive. And once we've got all these motifs, then we said automatically, now we can do raga ID and so on. And we did what is called raga verification rather than ID, because that's what most of us do. You say it sounds like this. So here is one that says there is So what's interesting is it tells us it's more Vrindavan Saranga, but actually it's Kapi. And we have to do some cohort normalization. And when we do the cohort normalization, it's one of the techniques in machine learning, you actually get the raga right. So this is what we did. And we have extended this to 182 ragas. And there was something interesting that we found. we found that in the initial portions of the Alapna, as Preeti was saying, this is Todi, Shankaravarnam and Natai, totally different ragas. They look very, very distinct. But towards the later portions of the Alapna, they look so similar. So, this is something that I always keep saying, that the artist actually establishes an outline and then takes liberties within that outline for a raga. And so towards the end, sometimes it can be pretty confusing. I remember there are many times that people criticize, oh, this was not really anything. And then we also did other work on looking at, there's always this confusion about, in Carnatic music, there's a Melakarta and the Jani Raga and Janaka Raga. And we found that it's very interesting that it has agreement for many ragas that are subsets of Sampurna ragas, but a lot of disagreements are observed across different metrics. For example, Mohyam, Mohanam, Janya Raga and Harikombodi Janaka, for example. And this is actually, it's interesting that it actually has a family of parents and not a single parent. We use various kinds of machine learning metrics to kind of validate this. And I think so what the artists are saying are actually quite correct. We also did, I wanted to show one more, oh yeah, sorry, I just missed this. Now, recently what we had done is, there is no score for Carnatic music. And so we said, can we kind of quantize it and give it a descriptive representation? So quantize it in terms of what are called these constant pitch notes and these stationary points. And we simply interpolate between them. And we find that the bit rate is very, very small. And this was the most recent work of my student who just graduated in December. And I just will play for you, close with this. This is the original audio, what we have been able to achieve. Let me play this incised audio. I've not played a complete one here. From the constant pitch notes and the stationary points. And what we do is we play it along with a and I'll just play one Riti Gaula example just without the accompaniment. So that was reproduced from the constant pitch notes and the, going back to the picture that I have here, this is exactly what we do. These are the constant pitch notes and the stationary points. So we quantize it in terms of constant pitch notes and the stationary points and simply reproduce the music. The bit rate is very, very small, much less than MIDI and so on. And so in conclusion, I said different aspects of vocal music, and we've done various kinds of things, but still a lot of work to be done. we actually have to come up with we have to relate the descriptive and prescriptive notation, because we cannot do away with the prescriptive notation. And is there a relationship between the lyrics and the melody? And I think there is. We have a lot of work to do. And we've done other works, segmentation of tabla solo, peshkar, kaida, gat, tukda, chakradar, and so on. We've done Gharana recognition. And currently, I'm also interested in cognition and music. We're looking at Drupad and EG. And source separation, we've done composition and percussion. We've diarized Taniyavartanams if there are multiple artists. We also done artist identification from the Mridangam sequences. We have done. We are also working right now on segmentation on Abhipraya, Korappu, Paransmara, Kodvai, and so on. And finally, is there a universal language in terms of which percussion strokes can be represented? Something that we are really looking at. So there's a huge acknowledgement, a lot of people, and of course, thanks to my collaborators from across India, and thanks to Preeti for providing us very nicely all the codes that were required for generating the music. Yeah, so that's it. Thank you very much. Hello.
Thank you, ma'am. So there are a few questions, and then I've been answering them as we kind of went through the talk. Do you want to add more things to that? For example, there's a question around. So this is a general question. The music is culturally sensitive, and by exploring computational aspects, will it actually contradict the traditional and generationally evolved protocols? My take on that was, of course, it's. I mean, this is typical for a lot of areas of work, and then because it's a socio-cultural phenomenon, as long as we involve the communities who are involved, like musicians, musicologists, music students, listeners, and MIR researchers, and then kind of arrive at common problems to solve, then it is most likely going to be consistent with what everybody needs within the field. So I mean, as long as we don't exclude the involved relevant communities, we will make sure that we will not be inconsistent. That's my take. That's what I've answered there. Do you want to add to that?
I didn't get that question. What was it?
The question is, because music is culturally sensitive, and because we are trying to explore computational aspects here, will it actually contradict our traditional and generationally evolved protocols? Essentially, are we going against tradition? This is my interpretation here.
But that's true of language also, right?
Yeah, it's true of
The
language, it's true of
language is the
cuisine.
same thing. So,
Yeah.
and I think anything actually evolves with, for example, even music, for example, has evolved a lot. Before the mic came into being, people never sang in Mandaristhai. Males had a tonic of 5. Women sang between 6 and 7 to be heard. Then you cannot do a lot of these variations, and now people are singing at much lower and lower shrutis. And the Madrasa is so beautiful today. You hear a lot of Mandaram in if you compare it with the 1920s, 30s music before the mic and after the mic, things have changed tremendously. So it's also evolving. If it doesn't evolve, it doesn't ceases to be a language. If you think music as language, I mean, that's my take on it. It will evolve with the technology.
Yeah, that's true.
Culture. Yeah. Evolution is also part of culture.
Correct. Yeah.
Yeah, and actually what we are touching upon is only one aspect. When you read about ragas and their description, there's a lot of aesthetic and emotional, terms used to describe, which is a really important part. It's all talked about together. So by analyzing audio, we are only looking at some of those technical aspects, and obviously further research is needed to link them to the cognitive aspects and the kind of, emotions that might evoke and so on. So I think, all of this really plays an important role in, achieving a more complete understanding of the music.
Right. Yeah. And then there is another question around, have there been any experiments with large language models? Like ChatGPT is quite popular these days, to generate new ragas from existing MIR corpora. Well, not specifically in Indian music context, but then, I mean, of course, a lot of ragas are, well, grammars. So it might be possible to use large language models if you can get large amounts of data to train them, actually. But yeah, I mean, I'm not aware of any work so far that has been done in this context. Yeah, I mean, and then
I don't
there's
think there's
other,
a
sorry,
chat
go ahead, ma'am.
GPT for, I mean, I don't know whether we want a chat GPT, but I do not know. Maybe it will give you some idea. See, one thing is, whatever we look at, I mean, even chat GPT, right? You should know what you want. If you don't know what you want, it'll give you garbage answers.
Yeah.
So in much the same way, if we can quantify what melody in Indian classical music is and say this is what I'm looking for, then maybe you can generate.
Yeah.
It can give you ideas.
It solves the problem of search. ChatGPT makes search easier, but then discovery is still as equally
Discovery is
hard.
still-
And
No, it
then,
was
so that is
quite.
where we want to contribute.
I think people also ask you to generate poetry like X and Y and all
Yeah.
of this. That. You're getting, most importantly, getting the emotional aspects, whether it's language or music, I think is still a very difficult task in the AI models that we have today. If you look at the text that ChatGPT generates, it's quite unemotional and quite insensitive at times. So ChatGPT is not there, even for language. So where is it? Music is going to be much harder for it to be there.
Yeah, in fact, that also answers the other question. Are we approaching a stage when computers/AI will generate all our classical music completely? Not there yet. So generate music, there are multiple layers there. Like one is, of course, to just build these skeletal notations, which is like generating words from a language. But then somebody needs to speak it out, right? I mean, or sing it or perform it. So that again is a lot of expressive things that come in, and then lots of virtuosity and lots of people coming together to create that. And yeah, lots of things involved there, and then not there yet.
Yeah, even deep fakes in voice for speech are not there as yet.
Yeah,
You very quickly detect it. In its deep fakes in video is a little harder. I mean, to detect, but in voice you can very quickly detect it because it ends up becoming robotic. There is a timbre that is involved when you speak, and that timbre is not there. And the timbre or timbre or whatever you call it, that needs to be put back in, whether in voice or in music, and it's just not there in. Because we also, whatever we have done also is only melodic reconstruction. We have not put the timbre back. When you put the timbre back, maybe, I don't know. But I think still it's quite a long way out.
right. Yes. Well, I mean, I think that there's a question by Dhanajan. What's the website that you mentioned at the beginning of your talk? Do you remember? I could not catch that. Do you have the website that you mentioned at the very beginning of your talk?
She talked about the Comp Music website. Who?
Com Music website. Okay.
Yeah, Preeti Rao, right?
No,
Preeti Rao.
you, ma'am.
What did I talk about? Sangeetapriya.org.
Sangeeta Priya.
Sangeetapriya.org. It has a huge collection, and now they've done a lot of filtering by which you can do a few things, but still it's not yet there.
Right. Yeah. Right. So maybe we can take again. Please keep the questions coming in. We'll try to answer like all of them in a follow-up Q&A as we finish the last part of the talk as well. And then so we kind of heard a lot about one overall picture of MIR and also on a lot of melodic aspects. I want to kind of brief upon a few of the rhythmic aspects of Indian art music, and then some work that we are doing with respect to that. So maybe let me take over and then kind of share. Okay, I presume you see my screen. So well, I mean, so just to motivate. So one of the questions that we saw was what are these things useful for, right? I mean, and then one of the ways that I kind of trying to communicate is say for example, if you go to Spotify or Amazon Music today, and then you want to search and then like listen to music. So the typical navigation that we use is we start from an artist, say A.R. Rahman, then we go to an album, say Dil Se, and then we ask for a particular song name, right? So that kind of a navigation is useful for a lot of kinds of music, but then how do we kind of use that? So, but that's not a very relevant way to kind of discover and browse through Indian art music collections. So where I want to kind of, if we want to really do this correctly, I want to kind of make queries such as play a slow kriti in Mohana Raga and Vishnu Chaputala. That's a query instead of this artist, this album, this title. Or I would want to say make a playlist of Drut Tintal Bandish that contain improvisatory sections. And then I might also want to do a query, get other songs that have similar rhythmic passages, right? So these are the kind of queries, complex queries that we want to make and then discover music, but then that's not possible as of today. And then that's where I think most of these MIR techniques are also going to be useful eventually, right? So for example, some of these aspects, like Kriti, Mohanaraga, Mishra Chaputala, Tintal Bandish, these are editorial metadata. So they are associated with the recording, and then they can be immediately inferred because the publisher, whoever has published that music, would have that information. But what do we do about these other aspects? Like, so what is slow here? So what are improvisatory sections? What are similar rhythmic passages? So these are the things where we need engineering formulations. So so this will help us to kind of have an enriched understanding and then our interaction with music, wherein like we can use editorial metadata, which is the information that we get along with, say, a music recording, and content-based descriptors, what's happening in the content. So there was a question on Shazam. So Shazam uses some content-based fingerprinting to kind of remember some salient features of a particular song, and then search is based on that, right? And then we want to kind of use this to organize very large collections, like collections such as All India Radio's entire music archive, which has like so few 100,000 hours of audio, for example. And we want to organize it using similarity measures. So a lot of work that Professor Hema Murthy and Professor Preeti Rao mentioned was about similarity, wherein like we saw how our phrases being similar to each other, how our ragas being similar to each other. So we can use all of those things to organize our music collections. And of course, Indian art music. So there are when we say there are two broad like dimensions. One is melody descriptors related to the raga, and rhythm descriptors related to thala. So I kind of will focus more on the rhythm side of things here. Right. So well, and then I think just to kind of emphasize here, comp music was to build culture aware music information research. So we are completely embedded in the culture, and then we want to bring music knowledge into methods. So whatever we develop, we want to bring as much music knowledge into that. And we want to convert music concepts into engineering formulations, as Professor Preeti Rao was mentioning, and involve music communities. This was like three broad goals of the project. In fact, so this is the way we kind of be inclusive and then ensure that we solve problems that are relevant to the communities. And then, I mean, of course, and we kind of are in line with the tradition as well, as much as it's necessary. Right. Just to quickly give you a very short introduction to musical time. Yeah, right. So musical time as we speak is similar to our normal time, except that so in music, time is in terms of there is an inherent periodicity of events in music. Things keep repeating, and it's called a small pulse. It goes like click, click, click. So for example, and based on that, we can define these note durations and tempi as well. And then there are two broad aspects of like musical time. One is rhythm, the other one is meter. And then, so let me, if I go here and define rhythm and meter, rhythm is typically the recurrence of events in time, and through which we can define rhythmic patterns. So if we have a daily rhythm, right? So which kind of says we wake up in the morning, do a number of things, and then you go back to sleep in the night. So that's the rhythm. And then in addition to that, there is a meter on top of it, which is hierarchical grouping of these events in time. So rhythmic patterns with a distinct hierarchy, which says that, okay, this event is more important than this event. And then this event is more salient than the other event. So then we attribute a meter to that. So meter is essentially what, I mean, the closest equivalent to a thala in Indian art music is. So if within Indian art music, so just to kind of brief you on the concept of thala refers to a time cycles, which kind of give us a broad structure for repetition of melodic and rhythmic phrases and motifs and improvisations. It has a typical structure based on the hierarchy, as you see. So you see that the long ones are important, like they are the beginning or the end of the cycle. And then you have other probable like events in the whole cycle, which are more important, right? So this is in Carnatic music. There are the notation itself, the terminology itself is not very important, but then the important thing to understand is there is a hierarchy here. And then there are different talas with different structure in each of our music like traditions of Carnatic and Hindustani music. So this is what I want to kind of emphasize here, that it's not one kind of rhythmic structure and metrical structure that's used, but there are wide variety of them. Say for example, so we can actually annotate audio with these kind of events. So there are, say for example, this is a cycle of 8 beats, 8 different eight different beats that can be divided in the entire cycle. And then the first beat is called the sama, the starting of the cycle, and then it kind of, it's a cycle, so it goes 1 to 8, and then it goes back to 1, right? So if you hear, maybe let me play this audio recording. So you will hear a click on each of those like beat numbers. You will exactly see how things are progressing in the cycle as we kind of go further. Let's listen to this. Are you able to hear this?
Yeah.
Okay, yeah. So you saw the phrases are repeating out every from 1 all the way till, and then you can see the pattern also here. You see that repeats from 1 to 8, then it repeats again, right? This is what is providing a framework for like arranging events in time, and then this is like the framework of Tala, right? So this is, and then in addition, in Indian music there is something very unique, uh, which is that in percussion in both Carnatic and Hindustani music, wherein the strokes of the main percussion accompaniment that is used in both of these music cultures, they are described in terms of syllables. And this is something which is quite kind of related to our language. So there is a language for percussion in both Carnatic and Hindustani music. And then that could be used to kind of describe rhythmic patterns and then percussion patterns as well. Right. Then, I mean, of course, so they are also onomatopoeic. So essentially, you would say the exact syllable that represents a particular sound on the mridangam in the way that it should sound. I mean, so it's onomatopoeic. So the syllable that's used is representative of the sound that the instrument produces, right? Similar concepts exist in Hindustani music as well. Like there are metrical time cycles. And then the one distinction is in Hindustani music, there's a concept of tempo classes. So because there is a wide range of tempo where the pieces are played, there are very slow pieces and then there are quite fast pieces. So that's a distinction here. And then, I mean, of course, there are also very distinct tals in Hindustani music. And then the same concept of syllables to represent tabla, which is the main percussion accompaniment in this Hindustani music, that also exists in Hindustani music. So the reason I kind of provided you this short background is to kind of say, how are these concepts kind of represented and then like analyzed using our engineering formulations, which is going to be the remaining of like few minutes of my presentation here. Well, the other important in Hindustani music is that each tal, the cycle of a tal is represented using a canonical rhythmic pattern. So for example, this ek tal, which is a cycle of 12 matras, 12 beats, it is represented with then sa dhage tirukita tunna katta dhage tirukita dinna. So this is the basic pattern that is played on this tal. So this could be used to kind of analyze where we are in the entire cycle. So if I were to play this particular pattern, right? So this is a pattern, and then based on this, I can identify where I am in the cycle. So these are like clues that we have. So if I were to quickly summarize this, right? So both Indian art music traditions, both Carnatic and Hindustani music, they are oral traditions and they are quite improvised. Tala is the basic skeletal rhythmic framework in both of them. There is no metronome that is used, unlike a lot of, say, popular music, which means that there is a bit of flexible timing, but there's a wide range of tempo in Hindustani music, smaller range in Carnatic music. And then there is a surface rhythm, so which is essentially all these little events of tabla and then little events of melody that are happening that are indicating underlying structures, metrical structures. And then there are well-defined syllabic percussion systems in both of them. And both of them have unmetered forms, like alap, for example, right? Alapna and alap. So they are unmetered, and then they're like typically beyond any rhythm analysis analysis problems, but then like they do have unmetered forms. So based on these observations, right, we can start looking at like some basic content description methods based on rhythm here, right? So and by going all the way from simple to complex, like say onset and pitch. Onsets are, I'll show an example of onsets. Like these are events in time that we predict. And then once we have onsets, we can detect meter, which is the tala, the tala structure. Once we have that, we can segment audio recordings into smaller parts, like something that Professor Hemamurthy was also mentioning of segmenting the whole concert. Then from those segments, we can extract patterns, and then we can define similarity between those patterns and use all of this information to organize music collections, right? That's the basic idea. So just to give you a few, very quick demos of things here. Onsets are basic events in time. I'll play an example, and then the periodicity with which the onsets occur kind of gives us an idea of tempo, right? So let me give you an example here. You will start hearing a click sound wherever there is an onset detected in this recording. Let me start playing that. So you heard those click, click, click sounds, right? So those are exactly the onsets that were detected. How did we actually detect them? So typically onsets are like, so if you take a signal processing approach here, these are transients. So where there is a sudden attack. So I hit a drum and then there's a sudden attack that comes up. And then typically onsets show up like that. It's not always that there are percussive onsets like that, but then onset is any change in spectral content. And that's what we use. For example, if we take a spectrogram and then look at it, so these little things, which are, these are onsets on the right of the mridangam, for example, and then these onsets on the left stroke. So we can use techniques such as, like you take the original signal and then kind of look at how the spectrum of the signal is changing over a period of time. And then that will in fact tell us, and then give us an onset detection sort of function, right? Which is this detection function, and the peaks of that, for example, gives us onsets. So just to illustrate, like what are the some kind of signal processing approaches we can use to detect these onsets, right? So, I mean, spectral flux is one of them. Flux is essentially a change. The spectral flux talks about the change in spectral content. And then based on that, we can actually detect onsets. So, I mean, so this is an onset detection function, if you see, based on this. So the peaks of this tell us there is something important changing there in the spectrum. And then these are very good candidates for onsets, for example, right? So, and the period between these onsets, we can kind of accumulate and then aggregate them and then kind of plot these tempo curves, which tells me what's the most salient tempo, what's the most salient periodicity that exists in the piece of recording that we have here, right? Okay. Yeah. And then, I mean, of course, we can do Fourier analysis on top of the onset detection function, and we get something like this. So if I show you this example, like the x-axis is time and then the y-axis is tempo. And then you see it kind of gives you a nice line of how the tempo is progressing over the entire music piece. And this is typically an expectation. Well, a lot of Indian music recordings, they kind of tend to get faster and faster as the piece progresses. So that's what you see here, for example. Right. So then comes like once we have all these onsets, right? Now we can put a structure to that and say this onset is the start of the cycle, this other onset is not, for example, and then so on and so forth. So at the end of it, so we arrive at an example like this, wherein like I've marked the structure of the entire tala on the audio recording here. So you'll see there is an X. The X starts at the start of the cycle, and this is a cycle of 3 beats. It goes as 1 and 2 and 3. 1, 2, 3. So that's what you can hear here as well. Like listen to, there are 2 different clicks, one for the start of the cycle and one for the other beats. 1, 2, 3. 1, 2, 3. 1, 2, 3. So this is an automatic extraction, by the way. So this was extracted through one of the approaches that we proposed during that work here, right? So this, what is this helping us? So this will help us to kind of mark these salient events, for example, on audio, and then we can organize these music collections so much more better, or extract parts of audio recording which are much more relevant. If I ask a 30-second summary of this, we can pick out at the places where the cycle is starting, because that's where the phrases also typically tend to start, right? So this is in Hindustani music. The cycle length is much longer here, but then let me kind of skip playing the audio. Let me play this. So to understand, like, so there you heard the beats very clearly, right? It went as 1, 2, 3, right? So very short beats. But here you'll see the beats are separated by about 5-6 seconds each. So this is beat number 1. That's X here. The next click was here. You saw? So how far each of those events are occurring. Right? So now we're still here. So this is a cycle which is about 60 seconds long. So it's quite a long cycle then, right? So yeah. So this like, so there are multiple methods to do this. And then of course one of the chapters in my PhD thesis was on this. So if you are interested, please go look at it. But basically it used a machine learning framework there to kind of build a dynamic Bayesian network to kind of track these events over a period of time. And then looking at, so basically we say that there is something in our observations, which is all the onsets and features that we extract. And then we want to kind of impose a particular metric structure on top of that, then in a statistical framework. And then, so that's the basic approach that was used then. Right. So what are the applications that we have built with this? So Dunia is one of the applications. This is for English music listening. So this application brings together not just our work, but also a lot of other work from Melody, and then so work from Professor Hemamurthy and Professor Preeti Rao's labs as well, together into a music collection, which can be used for enriched music listening. It provides things such as histogram of pitches that existed in the recording, the pitch track, and then, for example, the tempo information. And then this is a tempo as it is varying here, and then some more information about the tonic, which raga was that, which thala was that. So this helps us to kind of understand and appreciate this music traditions better. Right. We also built a music like an Android app, which kind of shows all this information on a particular recording as well. So that's available on a Play Store if you want to check this out. So if you want to kind of work on some of these topics, so there are some resources available, right? This again, some of them are from ComMusic. So there is a community Carnatic corpus, which not only contains audio recordings with all these annotated features, but it also has some metadata with respect to artists and then raga thala composers. It has some lyrics, and also it has contextual information from different multiple sources organized together. There's an equivalent Hindustani corpus as well. And then there are specific data sets, like say, for example, if you just want to do thala tracking, or if you want to just do tonic estimation, there are data sets for us to kind of build machine learning systems for that, right? And then importantly, there is an open access Indian music corpora. Most of the music that we listen to is copyrighted, so we cannot use them as it is. So what that would mean is, we are always bound by copyright rules. So we kind of went ahead and then collected audio recordings, which can be openly shared using Creative Commons licenses. And it has about 40 hours of Carnatic and Hindustani music annotated. And then if you go to mtg.github.io/saraga, you can get access to that data set for your work, right? So basically so these data sets, they are available also through an API. So if you want to kind of pull these data sets to do some experiment with them, so there's an API available to kind of access these data sets as well, right? So I'd like to thank all the collaborators I've had the fortune to work with over the past several years, which includes Professor Preeti Rao and Hemamurthy as well. So thank you so much. So let's that's been my presentation at least. So maybe let's take up some questions at this point. Yeah, thank you. So there are let's move to some existing questions. Of course, music has, of course, a lot of other roles in addition to typically what we use it for listening. And then, I mean, of course, so like people say so language, right? I mean, is again a form of spiritual communication. We talk to, I mean, so, and then similarly cuisine as well, right? So we cook, and then so some of it is just our food, some of it is prasadam. So unfortunately, at least so music is a form of spiritual communication, possibly. Can AI do that? I am not too sure about that. So it's not, say, typically as scientists, we do not tend to kind of go towards metaphysical things. And at the same time, also look at things that have a very clear relevance to our existing technologies. So that's just something, so beyond at least my understanding and expertise here. Yeah, anything you want to add there, ma'am?
Yeah, we don't really have the tools to measure. Everything actually can potentially be scientifically, analyzed and documented. But there are many gaps in terms of understanding cognition and, influences that music might have on humans and so on. So if the tools become available, I think, an objective analysis of many of these concepts can be carried out.
Right.
I would like to just touch upon our work on Drupad music and making people listen. And there actually you can almost clearly make out when a person knows the music form and is listening. There is a nice, across sessions you'll find a similar pattern. But what was interesting was even non-musicians with Drupad, actually they go into what is called as, you start off with the relaxation. The alpha waves are very dominant. And then you actually see the nice delta wave coming in where they go into deep sleep. So I don't know whether it's a good thing. It might be a good thing. We do not know. When you look at cognition, and of course, the other thing about conscience, I don't think we understand what consciousness is. It's still unknown even to neuroscientists, and a lot of questions about it. We don't know.
Right, and within MIR itself, like we are actually still working on something much more basic, something that a lot of people agree upon. Like say, I mean, at least the entire music community agrees that a particular recording is in a particular raga, So that is when we as engineers can kind of step in and then kind of say, can we recognize this automatically, right? But if there is a disagreement within the community, then it's a much harder problem for an engineer to come in and then solve that. At least it needs to be kind of built bottoms up from the community there as well. Like some of these concepts, including like say the emotional states associated with music. So these are like very hard to analyze, and then like that's why you see very limited work on them as well. And so Vasu has a question. Do you think it's possible to build an AI tool which can identify a raga based on Arohanam and Avarohanam given by a user? So yeah, it's surely possible. In fact, we did a hack a few years ago called Raga Vice. I'll put a link to that here, which was doing something similar. You sing. As you're singing, it will kind of tell us what are the options of ragas that are possible with the phrasing that you're singing.
Yeah, but you cannot do too much with the Arohanam and Avarohanam because you have to sing it with the timbre, the correct.
Right. And gamakas are not included in
Gamakas, for example, there are also some anyaswarams which will be used, not necessarily belonging to the raga, and that is also very typical. You know, Kamudi will use the higher ni, although it is not there. So there are many such typicalities which are there, and I don't know. I feel what we have done the raga identification that we have done is scaled up to 182 ragas, whatever Jarsu has in terms of the comp music thing, and we have been very successful, but with the initial portions only, not with the later portions of the raga. It's very different. That's something that we have noticed. It's possible. It's not difficult to get. In fact, it's very interesting even now when you watch music. Although it uses a lot of metadata, it will actually make suggestions of a similar kind. I mean, I'm very impressed with some of the YouTube suggestions that it gives today. I'm not sure it's not using melody. Yeah. For example, when I'm looking at Anand Bhairavi, it will next suggest to me, why don't you try Riti Gowda? You know, it's an interesting thing that I don't know what you're using. I'm a little curious to find out.
That could be collaborative filtering.
Yeah, something is happening, but there is something that's being done. And also, you know, artists, if I'm looking at Bombay Jayashree, it will also suggest Amrita Venkatesh and people with that kind of timbre in the voice. So, I mean, I'm noticing this very recently. I don't know what they're doing. So something is being done.
Yeah. And again, just to kind of follow up with you, ma'am. So at a very basic level, would it be possible to correlate types of music to be recommended to enhance focus and cognitive abilities of students, school students in particular?
Yeah.
So,
I mean, this is what we're trying to do in the context of the EEG work. In fact, our Dean of Students asked, can you do that to calm people down, especially after the recent things that have been happening in IIT, so various IITs for that matter. Is there something that we can calm the brain?
right. Yeah.
Something people are looking at. There are devices does a lot of, it does calm the brain, sleeping patterns get better and so on. So we don't know.
Right. Yeah. In fact, I mean, well, yeah. So there is a lot of work that is going on around that. But again, so are there like, so maybe something specific to Indian art music is something that needs to be taken up as well. And then I mean, well, so if and then to kind of, this is an empirical verification of what say people have been knowing for a lot of time, and then now we just verify it and then make sure that it's scientifically valid. Yeah.
See, one of the important things of the work, that the final one which I played on the synthesis, is that we can get it played at any tonic. So you can sing along like karaoke, you know, and find out where you're making mistakes. So at least that part we can do from a learner's point of view. And, you know, in fact, we have a very recent request. Someone wants us to do slokas. And it's interesting, it's not that slokas don't have melody, they have melody. They use only 3 notes. And we are doing a combination of speech synthesis and music synthesis to reproduce the slokas. We've got the intonation right. but we have not got the lyrics right. So we're struggling with that right now. So it's interesting that that is also something. The nice thing is it's a teacher which will not say you're doing Besur. You can imagine, and a teacher will say, I don't want to teach you because you're too much Besur. And at least computer will say, okay, keep trying. It will give you feedback at least and tell you that this is where you're going wrong. So that way, there are many, many applications that we can build for anybody to learn music.
Right. Yeah. It's good. I will again switching gears. So the two questions on archives of All India Radio are also essentially are Akashvani. So the archives of like both Prasar Bharati, right, which is owns both Doordarshan and all radio archives. So they are not in a form that is like easily shareable with public, and that's in fact a very good effort if as a community, MIR community takes it up
Yeah,
to ensure that.
actually, they've started putting a lot of things online now.
But
Many,
again, it suffers from the same problem of searchability. How do we
yeah,
search
yeah.
for a
No,
specific
no, but the point
content?
is maybe
Yeah.
it's a good thing to take those things in because the recordings are pretty good. A
Yes,
lot
they
of
are very good.
recordings
They're
are
very good.
available.
Yeah.
And if we can kind of put it into some kind of an archive, at least searchable on YouTube, that would be very nice. You can put a wrapper
Yeah,
around.
but the metadata needs to be a little thorough.
Yeah, but
Correct.
actually, no,
So
the
they need
point
to,
is, it's like Sangeet Sammelan concerts are all available where they're making very good announcements. Even if you did speech recognition on that and got the details in terms of metadata, and then use that to kind of label that YouTube, that podcast which is there, I think it will go a long way. There's a nice app also that's available. A lot of things are coming out now. It's very interesting. And recordings are extremely good. That is that's something which is really, really nice. Yeah. It's possible, perhaps.
So the other question, I mean, again, large language model equivalent for Indian music. So there again, I mean, see the Indian music or music in general is several things. So the audio and the symbolic music which is associated, that's one aspect. Then there is a lot of discussion around music and concept descriptions around music, right? So which talks about how concerts were, like say how the concert reviews, for example, or like how artists are related to each other, or stylistic commonalities, or like so all of these things can be included, and then we can build a large language model which can be used for queries such as so what like say things such as what were the other concerts in which say T.M. Krishna sang this particular raga, right? So those kind of queries are possible, whereas like queries that are like looking at a lot more into the music content at this point in time, there's not a lot of tools available for that. In fact, as a part of heritage initiatives like so Indian heritage, and then kind of looking at answering queries around Indian heritage, which music is a part of the heritage, right? So there is a large language modeling effort that is being taken up, wherein we want to kind of build a chat GPT kind of interface wherein we can go and ask questions about Indian heritage. Say, talk about like, so where is this music from? And then this applies not just to Indian art music, but also folk and film, and then extend it to all forms of music. And in general, also about architecture, cuisine, things such as art forms. I mean, both performance arts, but also handicrafts and everything. So it's a part of the whole heritage deal that's being planned out. Of course, music is going to be a big part of that. So there is about some data available to that, but then there needs to be kind of tuning and then like to ensure that it's available better. Yeah.
and in Western music, actually music generation, there's a lot of working from written music, that is symbolic notation. So, we don't have those kind of archives, and working directly with audio, the problem of the time scales is very large because there are samples and then there are, slightly larger time scales, and then music involves a lot of structure, which can, extend to several minutes into the future and so on. So working directly with audio is actually quite challenging.
Right. Large music. So, Rajnikant, do you want to kind of explain this question a little better? So large music model to kind of generate music. Is that what you kind of intend here?
Who asked that question?
So this is one of the open questions. So it's a large music model.
Okay.
Yeah.
Rajni,
So while this is the last question there, I mean,
he was thinking about synthesizing music. So he's talking about music generation.
Yeah. Well, I mean, that's where I think, see, if you have a lot of symbolic music data available, then things such as these could be kind of attempted. But then given that Indian music notation itself is skeletal and it's very prescriptive and not very, it's not descriptive at all. So then it's just a matter of, we can of course generate symbols and then say, okay, this is a music composition that was generated out of ChatGPT. But then unless it's actually rendered with all the nuances of Indian music and then like all, including Gamakas, timbre and aspects that we're mentioning, so it doesn't become like an Indian music composition per se, which has been rendered correctly. So that's why I think it's so layered that like some things are possible, some other things are much harder to do.
Yeah, but you know, Ajay, to kind of contest that, no, we found that see in fact, even the constant pitch notes had some standard deviation, and the stationary points had significant, up to 60, 70 cents, almost a semitone. And so across artists, no, it's not necessary that they are doing this. And in fact, there's a nice experiment by Subramaniam where he switched the Nishad, I think, and people could not make out that it was very different. Somehow there is a context in which we are listening, and I am not sure that in fact, no, we did in the constant pitch note and stationary point thing when we interpolated, we could not make out the difference between a linear interpolation and a cubic interpolation or a B-spline interpolation. All of them sound very similar. And then we have one other work where we showed that unless a note, you stand on a non-raga note for more than 300 milliseconds, I mean cognitively, which also is your P300 or effect in the brain, you don't perceive it as a apaswaram at all. So this is another thing which is very interesting. So I mean, I'm not one who believes that it is rocket science. There are nuances, yes, but there are certain standard movements that we do have. And even if you do some variation around the standard movement, I mean, somebody like Abhishek Raghuram does it all the time, or Krishna ties it in some ragas. So it's not that these things change it very significantly, and you like it. You say, okay, this is a new phrase, and it's being discovered all the time. There's no fixed grammar that we actually have. So I'm not sure. Maybe if you really come to a real large language model and it says, okay, here is a new beautiful phrase for Kambudi, maybe you can see, you know.
Yeah, that'd be good.
Because I just feel that, I mean, a lot of things which we thought, you know, I remember initially we felt, oh, the pitch contour should be absolutely exact and all that. We started realizing it's really not required. And, you know, somebody will say Dani Dappa, somebody will say, you know, Dasa Dappa. Some slight, you could transcribe it as Sa, or you could transcribe it as Ni, as Brinda Manikwachkan was telling us in the thing. I do what appeals to me. And in that thing, in the first histogram that I showed, there's a large bandwidth that it allows. Quite a large bandwidth, almost half a semitone, which is like 50 cents, collar of 50 cents on either side. You know, so it's giving you a lot of freedom in the Indian music. And I mean, I must tell you, some of my Western classical music friends don't like, especially more so Carnatic than Hindustani, and say, oh my God, it's very apaswaram, soft key. Okay, so it's also very culture specific the way we love these kind of variations that are there. And I think we take a lot of liberties, and that improvisation is part of the game. And if you go back again, now go back and listen to a Kambudi sung 100 years ago and listen to it now, they're so distinctly different. But still there is some skeletal Kambudi structure that is there, makes you identify the raga. So I think nuances are also changing. I feel our grammar changes, language changes, everything changes, I think. And that's the positivity of it, because that's how it lives on. You know, if it didn't change, it wouldn't live on. I mean, if you take a Bihag, no? Bihag is supposed to have come from Hindustani, but I will call it Carnatic Bihag, whatever we sing. It has been so Carnaticized, right? So there is very, so we adapt quite a lot, a chaya nut for that matter. Bilaskani Todi. I mean, people like Sanjay and all always for RTP, he'll take in his Sari Raga. And sounds very nice.
Right. Yeah. Well, I mean, yeah. So it's a very like interesting discussion there. Yeah. Again, so we've touched upon this question about like emotions and different ragas. So that's quite a hard problem to formulate because of lack of data and because of subjectivity involved. There is a lot of research possibility there. It's just much harder problem to solve.
Yeah, actually, we have only started right now. Different genres. I like this genre. I don't like this genre. Are you falling asleep? Are you not falling asleep? This is what we're being able to find.
Well, even further, well, at least a lot of like a lot of these experiments in neuroscience is even at the tone level, right? I mean, not even at like a specific sequence of tones.
As complex as music, yeah. Yeah, but it's all considered very important. So I'm sure there will be progress on that front. Yeah.
You know, in the context of disability, there's a lot of work on music and disability, and especially autism and things like that. Even in India, for example, there's plenty of work going on in IIT Kharagpur and Kolkata and all that, where they have found that there are certain autistic children who listen to a particular song of Rabindra Sangeet. That's what they have tried. And the child really calms down. No idea why. Okay. There's a lot of work that's going on this kind of thing, on getting music to be a form which will, which can perhaps be used as therapeutic or whatever it may be. Quite a lot. He's talking about Revati and Shubhapantwarali. Somebody else, it may be some other agam. And it'll be nice to see. And surely one thing is, when we do EEG analysis, we're able to see this, because you can look at the different waves and analyze them. But the work is very, very nascent. We have a very long way to go in that domain.
Yeah, Dr. Sushila, did you have any comments or questions?
So, Ajay, have we been through all the questions?
Yes, I think so. We've at least grouped some of those questions and then answered.
Yeah, sure.
Yeah, I think so.
Lovely.
Palgat Mani Iyer's question, yes. Yeah, that's a musical preference. Yeah. So he was a strong proponent of the idea that male singers should try to sing at higher pitch.
Yeah, but that's again, no, look at when Palgat Mani Iyer refused to use a mic for his Mridangam. Because it's true, the mic distorts. Okay. So there are, he had his own, of course, he never played for women also.
Okay, so
there's a question, Dr. Sushila, that will this session recording be shared among the participants?
It will. Okay. It will be. So let me start by saying thank you all for being here. And yes, the recording of this webinar, like every one of our webinars, is going to be up on the IITACB YouTube channel. By Monday, we should have it up. So please do look for it over there. But let me, before we conclude, I just a few takeaways. And of course, thanking all of you for this absolutely fascinating discussion. Bringing together various tools of technology to appreciate and understand our own culture is a very interesting development. And I'm so thankful to all of you for having taken the time to be here and explain to us what all of this is about. We started by saying that Indian classical music is culture dependent and sensitive, and we've heard that multiple times. While audio is one part of it, and today's focus was really on the audio part, aesthetics, cognitive aspects, etc., also need to be analyzed. to get a really get a full understanding of what our music is all about. While there are several theory texts, the oral tradition is still, and the way performance is done, all of that is still a gap that needs to be understood to be able to to get a complete understanding of what those texts really are implying. There are some key characteristics of the Indian classical systems. There is no score. It is not set to a specific key. There is no fixed pace, and improvisation is there in every part of the music, even in set compositions. So these are some key distinctive features of our music. We looked at how the analysis has actually been done, and three major dimensions of melody, rhythm, and timbre. We saw how using ideas such as continuous pitch distribution, the constant pitch notes, duration of the note, intonation, stationary points, etc. Using all of these concepts, how it is possible to analyze ragas, identify them, and even look for those phrases in various performances and songs. Interestingly, using the lyrical content of a Carnatic song music composition also can be used to identify a raga, because we heard from both Professor Preeti Rao and Professor Hemamurthy that the early part of a performance of a segment has more variability to it than the later part, and therefore the importance of being able to do something like that. We saw that other areas of research are things like sound-gesture relationship. So even if there is a similar singing of a particular composition by different musicians, the way they use their hands and other gestures is very, very different. I thought that was a very interesting kind of a problem to look at. We saw how rhythm can be analyzed, including estimating tempo, because we don't have a fixed tempo again. So, and then there are in Indian music performance, you have unmetered forms like the alapana. You have tempo that varies over time. So it's not something that is fixed throughout. It varies. Also part of the whole idea of improvisation, I guess. And the way that is all done is looking at onset and pitch and metering and so on. So then we came to this question of what is the use of doing all of this? And a few answers that I picked up from the discussion today. How can we improve our understanding of our traditional music forms? And for this, there are resources such as Dunia, which give you an enriched music listening experience. Things like comp music, which have corpora for both Carnatic and Hindustani music. And of course, then Ajay was telling us about the open access Indian music corpora at GitHub. I thought that was another interesting one. For learners, a karaoke kind of facility. So you can learn from your chosen maestro using something like that. Then being able to analyze concerts and listening to them also helps improve an understanding of what all of our music stands for. We had some very interesting discussions on things like, the spirituality and the metaphysical aspects. But as consciousness studies become more mature, and somewhere I was hearing someone say that it's probably going to take 30, 40 years to mature to a reasonable level, such questions, metaphysical questions, will also probably get answered. And what remains now in terms of questions that researchers could take up, lyrics and the relationship between melody and lyrics, recognizing a gharana from listening to a particular piece of music. And then, of course, the whole question of music therapy, EEG, etc., and the impact that music has on us. Analyzing huge audio collections, what can that really do? Can a listener choose what to listen to, not just songs, not just pieces, but on different dimensions. So, how can that be done? Then another very interesting question was, what is the actual Janaka Raga of, say, a pentatonic scale? Because you don't know, it could be so many other Janaka Ragas. Then timbre that gives richness to the voice. How is it possible to add that in electronically? Because if you don't do that, then your music generation of your synthesis is still not complete. And finally, we should expect that our classical music systems are going to evolve with technology and the way technology moves. Our systems are live systems that have been with us for thousands of years. And we should expect that this evolution is only going to add to the beauty and the liveness of this music over a period of time. I was also very impressed to know that the Indian heritage system is being put in place. So, we can, similar questions that remain, that we would like answered about cuisine and clothes and whatever else. Also, it will be possible to do that. Sometime back, a couple of years ago, we had this this webinar on Hampi. And I would very much recommend, some of our listeners who might be culturally inclined to go back and look for that webinar as well. So with this, I just want to say thank you ever so much for being here, Professor Hemamurthy, Professor Preeti Rao, and Ajay. Today was absolutely fascinating looking at how technology has stepped beyond, serious kind of issues, and we've had several webinars on a number of topics, but this is probably the first time we've really seen something that is so deeply rooted in what our culture and what we mean when we say Indian and so on. So thank you for being with us. And to our listeners, thank you for being here. Thank you for raising those questions. Every one of them has enriched today's conversation. And we look forward to welcoming you next month to our next webinars as well. So thank you and Jai Hind.
Thank you. Thank you.
Thank you, Dr. Sushila. Yeah, you had an excellent summary there.
That's very good.